On today's episode, we are getting into the latest space news, including a major Starship launch update, NASA shows off progress on their Viper lunar rover, Astrobotic's Peregrine moon lander arrives in Florida for integration into its Vulcan rocket, and rocket startup Astra is looking increasingly shaky as their funding dries up. This is the Space Race. Jumping in with some breaking news here, we have solid indications that SpaceX will attempt the second launch of the Starship Super Heavy rocket Friday, November 17th. This is according to Elon Musk, who posted Monday on X, was just informed that approval to launch should happen in time for a Friday launch. This is further reinforced by an FAA notice of restricted airspace over Brownsville, Texas. This was posted on November 14th and states a restriction beginning at 1300 UTC and ending at 1539 UTC. That's Coordinated Universal Time. It translates to 7 a.m. Starbase time until 9:30 a.m. That's the Central Standard Time Zone in North America. The FAA notice puts a red box around the area from Boca Chica Village straight out into the Gulf of Mexico, and the altitude restriction is listed as from the surface up to unlimited. So that's definitely clearance to launch a rocket. Now, we just have to sit tight and hope that everything goes smoothly on the ground. According to a flight schedule posted by SpaceX, ground activity will begin 2 hours prior to launch, and booster propellant loading will be underway at T-1 hour 37 minutes. Check out our Discord server linked in the description for a live watch party. With all of the activity happening on the moon recently from international space programs, NASA has announced that their own lunar rover Viper is ready for final assembly and testing, and they want to broadcast that process. The Volatiles Investigating Polar Exploration rover will be NASA's first independently autonomous rover to ever land on the moon, which feels weird to say, but I guess when most of the previous NASA missions involved sending people, there just hasn't ever been a need for them to have a rover capable of operating on its own before now. Originally intended to touch down on the lunar surface in 2022, Viper was one of the many projects delayed by the pandemic and has only recently seen progress on its assembly, just in time to keep its mission relevant for the overall Artemis program schedule. The main goal will be to find and analyze water ice samples, both to more accurately survey the places where a more permanent human installation might be able to gather the water necessary for survival on the moon, and also to catalog any potential useful substances below ground, which is where Viper gets the volatiles in its name. In geology, volatiles refers to chemicals that are dissolved in the structure of the rock or soil until exposed to the surface. Water is a common volatile, as is carbon dioxide, but the most recent subsurface samples that NASA has access to are the ones brought home by the Apollo missions of the late 60s and early 70s, which means that by now, all traces of any potential underground water sources have long since evaporated. So Viper has been designed specifically to look for these signs. It is, of course, equipped with a 1-meter drill to accomplish this task, but also a neutron spectrometer system to sniff out hydrogen levels, and a near-infrared volatile spectrometer system with a mass spectrometer to back it up. This way, the rover should be able to find large concentrations of hydrogen before even drilling, and then analyze those samples without needing to send them back to Earth. But that's only the primary mission, and Viper has another important trick up its sleeve. It's going to be able to operate during lunar night. Because it lacks any atmosphere, the moon experiences wild temperature swings as it rotates into and out of the sunlight, positive 120 degrees Celsius in the day, and then negative 130 degrees Celsius at night, each phase lasting roughly 14 Earth days, which is enough to freeze most electronics and mechanical parts solid. This is why other lunar robots, like the Chinese Yutu rovers, have typically opted to shut down during the night to preserve power in the hopes of reactivating during the next day cycle to continue working, or just opting to work as long as possible before dying, like India's Chandrayaan-3 lander, which recently completed its mission when it failed to wake up after its first night on the lunar surface back in September. Keeping a rover operating through this sort of intense cold would be very useful, of course, because aside from developing technology that would really help the rest of the space race, It would allow robots like Viper to study phenomena on the moon and other extremely cold bodies that we haven't been able to yet, like the electrostatic current that scientists believe forms on the lunar surface at dawn and dusk, which could cause a thin layer of dust to levitate briefly. Luckily, Viper's original schedule included a lot of time for setbacks. We are still almost a decade out from any serious attempt at establishing a more permanent human presence on the moon, so there's still plenty of time left for Viper's mission to study the water in the South Pole, which is now scheduled for a November 2024 launch. This also gives NASA the unique opportunity to stream the assembly and testing of their rover, a clever bit of media work that NASA doesn't often take the opportunity to do. The administration seems allergic to showing off their progress and the interesting technology they work with, even though some time with the public would be great for building some hype and landing some of the funding they need for their projects. So let's hope Viper's live streams are just the first of many new similar projects. Continuing the lunar lander news, Astrobotic has announced that their Peregrine lander has survived its trip from Pittsburgh, Pennsylvania to Cape Canaveral, Florida, and is being fueled and integrated into the Centaur 5 upper stage vehicle that will take it to the moon. The Peregrine is nearing the end of an almost 16-year journey for the Astrobotic team. It was one of the original recipients of NASA's Commercial Lunar Payload Services contracts, a program designed to give NASA the redundancy they need at the same time as allowing commercial companies to compete for lucrative agency contracts to bring NASA experiments to the moon for them. A win-win by all accounts. Several other recognizable names were part of the same competition and won contracts, including Intuitive Machines, Firefly, and Draper. All of these companies have solid-looking landers, but Peregrine is different for 3 reasons. The first is a more practical one, its design. With several of the more modern landers, you'll notice that several companies have chosen a pretty vertical design. Intuitive Machines Nova-C is made this way, and so is Blue Origin's recently unveiled Blue Moon, and of course, Starship's Human Landing System vehicle. There's nothing really wrong with this design, it should work without much difficulty, but Astrobotic chose a much more stable, wide-based design for their Peregrine that, while probably making it a bit of a pain to load onto a rocket, is definitely the most stable-looking lander we've seen lately. Its low center of gravity and splayed legs means that it will have a much harder time rolling than the more top-heavy designs from the other companies. The second reason is that Peregrine's first mission will include several pivotal NASA experiments and scientific payloads, which mostly include the usual batch of spectrometers and even a small rover built by Carnegie Mellon University. But the really important equipment is the Terrain Relative Navigation Sensor, which has been designed to provide some of the first precisely detailed terrain mapping explicitly for the use of later landings. Peregrine will basically land in the traditional manner, using satellite mapping data to make a best guess, as every lander has done since the Apollo missions made the trip. But after Peregrine, the TRN data will be used to land Astrobotic's next lander, the Griffin, in 2024, which will grab even more TRN data, building a larger map for use with Blue Origin's lander soon after that, and of course anyone else who needs it. In this way, Peregrine is acting like a scout for those later missions, at the risk of failing the same way recent landing attempts like the Hakuto R and Luna 25 did, but if they succeed, then landing will only get easier. And to help Astrobotic reach the moon safely, the ULA will be lending a hand, which is the last reason the Peregrine is so much different from every other CLPS lunar landing mission. Peregrine will be launched aboard the very first Vulcan rocket. The ULA's highly anticipated heavy lift rocket has faced several delays, but is a chance for the company to keep their reputation as a dependable launch service provider, not to mention allowing their Atlas V and Delta IV rockets to finally retire. This first launch was originally slated for 2019, but a series of delays and technical issues pushed it all the way back to the current date of December 24th, Christmas Eve. From there, the Peregrine will be ferried to the moon by the Centaur 5 upper stage, land by about late January 2024, and start taking data for 8 to 10 days before running out of power during lunar night. But while optimistic, no one is under any illusions. If the Vulcan launch slips or fails, the teams are prepared to find another launch date. If the Peregrine doesn't land well or fails to turn on or any number of other problems, Astrobotic will take that data and use it to prepare the Griffin lander. Suffice to say that both Astrobotic and the ULA have a lot riding on this mission, but they are both experienced aerospace companies, so it's not likely they'll need a Christmas miracle to pull off a textbook mission here. Steady as she goes, folks. The end is coming for Astra. Some of you might remember Astra Space as the company that tried and failed to launch the NASA TROPICS missions back in 2022. The spectacular losses of two fairly important weather tracking satellites provided a very embarrassing public look at a company who had only succeeded in 2 launches before attempting their ill-fated NASA contract. And it's not like they only failed 2 or 3 launches in total either. Across their launch vehicle prototypes named Rocket 1, 2, and 3, Astra failed to launch a staggering 7 times, including TROPICS, before slowing down to focus on ironing out the kinks in their vehicles and designing their Rocket 4 hardware. Since then, and really for the entirety of 2023, Astra has been struggling to court investors in order to keep the doors open and allow them to develop their next rocket, taking a couple of loans to do so. Things are getting so dire that the 2 founding members, CEO Chris Kemp and CTO Dr. Adam London, have offered to take the company private by purchasing its stock before their loans come due on the 17th of November. But could that even save the company? There are a couple of things the 2 founders could still achieve with Astra, but they definitely have to make some harsh cuts to the scope of their operation, likely dropping their plans for designing a rocket altogether. The real moneymaker for Astra seems to be their satellite business and the engines they've designed for their launch vehicles. The rockets may not fly, but by most accounts their kerosene-powered engines are a solid bit of tech. Honestly, stepping back and making some hard decisions here is likely the only way forwards for Astra. It's not easy to shake the sort of reputation that they gained from losing so many rockets, so maybe it's time to call it quits on the launch services side of their business. Meet us back here every week for more updates on everything aerospace industry and interstellar exploration related. Make sure to give the video a thumbs up today if you liked it. That really helps us out for real. And subscribe to the Space Race for more videos just like this. We do 1 long-form essay and 1 news update every week. And if you'd like more, we've got 2 more on the screen for you right now.